I'm sure these look pretty familiar from last year. Okay, these look pretty darn familiar. I'm sure many of you at one point last year probably got frustrated doing these because it just didn't come out to be a whole number and it was a decimal, and you're like, yeah, I know I should get whole numbers, and why am I doing this? As frustrated as you may get, I'm going to be honest, you need to answer these correctly to get to that 26. This is a must-have. There's going to be things on there a lot tougher than this. If we get one like this, we should be thanking a lot of people. All right, if we get solve an XYZ problem. First step, eliminate one of the variables. Pick two equations and let's try to eliminate X, Y, or Z. I'm going to guide you through this because you're going to be practicing a ton on your own in the next 6 weeks. I've chosen to eliminate Y. And I've started with equation 2 and equation 3. All right, so I'm going to have you guys do the same just to be all on the same page here. I'm going to start with equation 2 and equation 3, and I've chosen to eliminate Y here. So let me ask you guys, how do I eliminate the variable Y? Multiply the third one or bottom one in this case by 2. Got it. So I multiply the bottom one by 2. Distribute now all the way through. Negative 8x minus, or plus 2y, sorry, plus 2z, and this drives me nuts, darn it. Multiply all the way through. Don't just stop at the equal sign. All right, equals 32. All right. Combine your like terms now, x and negative 8x. Negative 7x. Everyone see how the y's cancel out now. What about the z's? How many am I left with? 7 z's. And then what about my numbers, 3 and 32? Okay. Now you got to do it again. You have to eliminate y again, but in 2 new equations. All right, 2 new equations. So this one, I took the first one. I took 2x plus 3y minus 4z equals negative 1. And I compared that with the last one again. Negative 4x plus y plus z equals 16. Now, I want to break. You can do this a ton of different ways. I just said, you know what, you could get rid of x first, get rid of z first. It's up to you. How do you get rid of y in these two? Multiply the second one by negative 3. All right, little help. 12x minus 3y minus 3z equals, is that negative 48? Combine your terms, 2x and 12x. 14x, 3y's are gone. What about the z's? Negative 7z. And then numbers, negative. Okay. All right, I've officially eliminated the y's. Now you need to get rid of another variable, either x or z, based on the 2 equations you were left over with. I hope you're going to say z, because I don't need to do a darn thing, do I? Okay, I can eliminate the z's now. So all I'm going to do is rewrite this. Negative 7x plus 7z equals 35. Write the second one I came up with. Yep, z, so I'm left with how many x's? 7x equals, and then on my numbers, negative 14. Come on. So x is, what's the value of x here? Negative 2. Okay, how can I find y? I'm not sorry, not y, but I could go back and get z now. Go back to one of your original ones here we made. You got your choice, guys. What do you want me to plug it back into? The negative 7x or the 14x? 14, okay, so 14 times negative 2 minus 7z equals negative 49. Negative 28. I'm not too sure what's this? Add 28, what do you end up with? 21, negative 21. So what's my value of z? 3, okay, and then finally, how do I get y out? Plug x and z into what? Any one of the original 3 at the beginning. Anybody got a preference? The first one? Okay, we can do that. So I can say 2 times negative 2 plus 3y minus 4 times 3 equals negative 1. Negative 4, negative 12, was that negative 14? Okay, I did something wrong there. It's negative 16, calm it down. All right, there we go. 3y equals 15, and y equals negative 2, 5, 3. And I know I've asked this before, but how long do you got to stay there in 6 weeks? 2 hours. Why do I ask that on this problem in particular? Yeah, real easy. Store them into your calculator. Store in X, Y, and Z. And just, hey, a quick mention on the check. For them to be actual solutions, it's got to work in all 3, remember. It can't just work in one. All right, it's got to work in all 3 to be actual solutions. And the second thing I'll mention before we put this one to rest, if you want to have any shot at getting these right, you got to be organized. Got to be organized. Okay, I can't have stuff over here and then all of a sudden, yeah, this is the way my writing looks, like I'm writing with the pen in my mouth and not in my hand. Okay, most of you got pretty decent handwriting anyway from what I've seen this year, so you should be okay. We all good? Okay, that's the only one I'm doing today. It took a while, so it's the only one I'm doing today. Okay, I'm going to do something I never do all year in any of my classes except for this day in this class, and that is show a video. Not really a video, I shouldn't say that, but just a, no. We already have Dolphins, though. How about that? All right, here is what we're about to do for the rest of the unit. We're going to read about different experiments, specifically ones where we put you into 2 different groups. One gets the treatment, the other gets the old placebo. And we will notice a difference, that the treatment group probably did better. But our question we need to start answering is, did the treatment group do better because of the treatment or just some random chance? That's what we're going to have to start figuring out over the course of the next 3 classes. All right. Did the treatment group do better because of the treatment or just by some random chance? All right. So let me just talk about a couple things first. So you see in this first exercise, I have 50 people, and we're going to try out a new diet pill for weight loss. All right. So I divide them into 2 groups. One got the pill, the other one got the placebo. Typical controlled experiment. All right. The people in the pill group lost weight. Did they lose weight because of the pill, though? So I want to talk first about the different types of what's called variability. There's induced, and then there's natural. Why did the pill group lose weight? All right. By induced causes. Here's what I mean by induced. The treatment worked. It was because of the pill. Treatment worked. Meaning, again, the pill caused the weight loss. That's what we mean by induced causes. Yes, the pill did cause them to lose weight. But what if it wasn't the pill? Then we have natural causes. Anybody can think of any causes that might make them lose weight other than that pill? Yeah. Exercise, right? Maybe not because of the pill, just because one group exercised a little more than the other. That's a natural cause, not the pill. Anything else that may have caused one group to lose weight, not because of the pill, but by diet? Yeah, maybe it was the diet. Maybe it wasn't the pill. All these other factors are called natural causes. One more I put up in there. Anybody want to say anything else before I throw my suggestion up? Metabolism. Maybe they got better metabolism and it wasn't because of the pill. Okay, so just don't think because that group lost weight, it's because of the pill. It could be for other factors. And that's what we're going to test over the next 3 days is it because of the treatment or other random ways? All right, here's what we're doing today. We're going to swim with dolphins. Okay, we're going to swim with dolphins. And we're going to find out that the people that swam with dolphins, when we retest them, they had lower depression rates. Here's what we got to figure out before we leave class today. Was it because of the dolphins or something else? Did that group have a lower depression rate because of the actual dolphin or some other random factor? That's what we're going to start testing. All right. So I'm going to start playing this video. It matches up with your packet. I am going to stop it at multiple times during this so we can fill out some of the stuff and I can just gauge that you make sure you know what's going on. All right. So enjoy here for a little bit. Can we see this, or do I need the front lights turned off here? Are we good?
I feel like we should turn off the lights.
Not all the lights. I don't trust all of you. All right. No. Good? Is that good? I got at least one set on. And this is not like a movie or anything, big Hollywood production, so don't get crazy here. All right, here we go. And I'm not going to blow it up to full screen because I need to go back and forth from your packet to... Okay, so if you guys could get on this page here for me, that's when I'm going to start talking whenever the video gets to that point. And my mouse just died. All right, so swimming with dolphins. Did it really lead to a decrease in the depression? There we go. Okay.
Published by Antoninoli and Reveley in the British Medical Journal. Swimming with dolphins can certainly be fun, but is it also therapeutic for patients suffering from clinical depression? To answer this question,
I know it's a little cheesy, but
whether or not swimming in the presence of dolphins helps some depression patients improve at a higher rate than other individuals that were in similar circumstances but did not swim with dolphins. The researchers recruited 30 subjects aged 18 to 65 with a clinical diagnosis of mild to moderate depression. The subjects were required to discontinue any antidepressant drugs or psychotherapy 4 weeks prior to the experiment and throughout the experiment.
This is just background.
These subjects went to an island off the coast of Honduras, where they were randomly assigned to one of 2 treatment groups. Both groups engaged in 1 hour swimming and snorkeling each day. The one group did so in the presence of bottlenose dolphins,
Bottlenosed.
and the other group did not. It's important to note that the participants in the dolphin group and the control group experienced identical conditions except for the presence of dolphins. At the end of 2 weeks, each subject's level of depression was evaluated, just as it was at the beginning of the study. Our response variable is defined as whether or not subjects achieved substantial reduction in their depression. Our null hypothesis.
You don't have to worry about this part.
Does not help. That is, whether or not someone swims with dolphins has no association with whether or not someone shows substantial improvement in depression. Our alternative hypothesis is that the presence of dolphins is helpful. That is, swimming with dolphins increases the probability of substantial improvement in depression symptoms. We can define our parameter of interest as the difference in the probabilities of substantial improvement between the two groups, which we can symbolize with pi dolphins minus pi control.
Okay, we're not going to call it pi dolphins and pi control. If you look at your paper right now, for the dolphin group, I call that P with the subscript D. All right, that is all the people who swam with the dolphins and reported a decrease in their depression. So can you guys help me look at your table right now, and we'll find this value. Again, that's the people that were in the dolphin group who saw a reduction in their depression. And how many of them were there? 10 out of how many in that group? No, in the 15. So 10 out of 15 reported swimming with the dolphins and a reduction in their depression. So 10 out of 15. Okay. P of C is for the control group. C for control group. So everyone who was in the control group, how many reported a decrease in their depression? 3 out of 15. So we all agree there's a noticeable difference between the dolphins and the control group. But is that difference really because of the dolphins? That's what we're going to examine before you leave today. All right, is it really because of the dolphins that this is so much more than this one? All right, now find the value of these two subtracted, because that's going to be a big value today. So I'm going to take 10 out of 15 and subtract the control group, which is 3 out of 15. And I want a decimal at least rounded to 3 decimal places, the nearest thousand for me. So 0.3 to the thousand. Point. Point 467. Okay, 467. We are going to refer to this as our observed measure. Okay, our observed measure, 0.467. Here's what it's basically saying: about 46.7, about 47% more in the dolphin group than the control group said they had reduced depression. That's what that means, about 47% more. Again, here's what we're going to examine. And just, I know it's a little dry and dull here. Is this difference because of the dolphins or something else? That's what we're going to test right now. All right. Quickly, what if that value came out to be negative? What would that mean? If this value came out to be negative, meaning this one was greater than this one, what would that mean? Well, that would mean what? More people in the control group had reduced depression than the dolphin group. Everyone agree? What if it came out to be 0? There's no difference, right? And that would be done with the study. There's no difference. But if it were negative, that would mean more in the control group experienced less depression than the dolphin group. And if it was 0, it means there's no change at all. No difference between But there is we all agree there is a huge difference. Okay. So let's start seeing if it's because of the Dolphins or not. Ready to go?
Thus, we can state our hypotheses as shown. Well, what did the researchers find? A summary of the results
This is
in
what we
two-way
just
table.
did.
We see that subjects in the dolphin therapy group were more likely to show substantial improvement. In this group, 10 of 15, or about 67%, showed substantial improvement compared to only 3 of 15, or 20% in the control group. Our observed statistic is the difference in the proportion of improvers, or 0.467.
That's what we got.
This appears to be quite a substantial difference. Now, there are two possible explanations for this observed difference. It may reflect a genuine tendency for depressed individuals to be more likely to improve if their activities include dolphins. In other words, the dolphins really helped. Perhaps, however, the 13 subjects were going to show substantial improvement and the 17 were not, just by being participants in this experiment, regardless of which treatment group they were assigned to. And we just happened, by random chance alone, to assign more improvers to the dolphin therapy group.
So you see what they're saying there is that why did this occur and why was it so large? Well, one of two ways. The Dolphins actually worked, or it was just by random chance we put more improvers into the Dolphin group. We got to figure out which one it is. We all good? I'm trying to go as slow as possible. Sorry if it's boring some of you. Actually, no, I'm not sorry.
Now let's think about how we're going to set up our simulation. If the null hypothesis is true, then the dolphin therapy is no more effective than the control therapy. And we were going to have 13 improvers and 17 non-improvers, regardless of which group they were assigned. Hence, the assignment of the subjects to the groups doesn't matter, and we can just randomly assign the subjects' results to the two groups to see what would happen under a true null hypothesis. We can perform this simulation with index cards. We will let 13 cards represent our improvers and 17 cards represent our non-improvers. We will then simulate the random assignment process of the subject to the two groups by shuffling the cards. Then we'll put 15 cards in one pile to represent the dolphin therapy group and 15 cards in another pile to represent the control group. This way, an improver is equally likely to be assigned to the dolphin therapy as to the control group. We will then compute the proportion of improvers in the dolphin therapy group and compute the proportion of improvers in the control group. Finally, the difference in these two proportions is what could have happened under the assumption of no association between swimming with dolphins and substantial improvement in depression. Let's try this out.
Okay, so here's the deal. Everyone see dolphin therapy. You had how many that improved? How many improved in the dolphin therapy? 10. So that's what these blue cards are, all the improvers. Control group, how many improvers did you have? 3. So that's what they did. And what they're going to do is they're just going to randomly shuffle, deal out 15 to the dolphin, deal out 15 to the control, and they're going to redo the numbers. All right, and then you'll see a huge difference here when they start doing this over and over again.
Here are cards representing the results from the actual study with 10 improvers in the dolphin therapy group and 3 improvers in the control group. We shuffle the cards and deal them into 2 piles of 15. In doing so, just by chance, we got 6 improvers out of 15, or 40% in the dolphin therapy group, and 7 improvers out of 15, or 46.7% in the control group. This gives us a difference in proportions of a negative 0.067.
How's that compared to the one we observed? Way off or right along with it? What was our observed one? What did we have? 0.467, and this came out to be negative 0.067. A little off, isn't it? Okay, and this was just by random chance that this happened.
Let's start making a dot plot of our simulated differences, with a negative 0.067 being our first
And this is
dot.
the dot plot that's at the bottom here of your
Now
page.
let's repeat this process.
So they're going to do it again, reshuffle, deal out 15.
This time we got 8 improvers or 53.3% in the dolphin therapy group, and 5 improvers, or 33.3% in the control group. This gives us a difference in proportions of 0.2, and we will add this dot to our dot plot of could-have-been values. We repeat this process again. This time we find that 7 improvers, or 46.7%, end up in the dolphin therapy group, and 6 improvers, or 40%, end up in the control group. This gives us a difference in proportions of 0.067, and we will add this dot to our dot plot. Note that none of these simulated results are as extreme as our actual observed difference of a 0.467.
Okay, see where that 0.467? It's way on the outside. All these ones that they're obtaining now happen by random chance. All right, happen by random chance. So I know 3 is not good enough, but are you starting to think now that our value didn't happen by random chance? We're starting to see that probably not happened by random chance. So what was the other? It's either by random chance or what? That the Dolphins actually worked. All right. All these dots here we're putting are by random chance, by reshuffling. So these are all by random chance, and ours is way out here. So ours is very unlikely to be by random chance. But is 3 good enough? 3 good enough? No, we got to do a heck of a lot more. And I know you want to see this again, so let's roll. So do I.
It is starting to look like this observed difference might be unlikely to occur just by chance.
Which we talked about.
But we need more than just
darn right we do.
Results. In class, I would have each of my students shuffle the cards and compute a difference in proportions. They would then plot those differences on the board, and the results might look something like this.
Okay, that's your dot plot at the bottom of the page.
We find that.
Do you see where ours would still be? Still way outside here, right? Is it, even though there's already a dot here, is it still unlikely by random chance? Yeah, it's still unlikely because all these here were by random chance. All right, so it's very unlikely that our value is by random chance. Okay, but again, is 30 good enough? No, we need more. We need more. All right. So then went online and did 100 shuffles now. Okay, and that's what's on the next page. So go ahead, go to the next page. So after 100 shuffles, where's our value now? 0.467. Still where? Woo! Way out here, right? So now that we've done 100, I think we're pretty confident in saying what? That this value, the difference didn't occur by random chance. It probably occurred because the Dolphins reduced depression. If our value came in somewhere here, it was probably because of random chance and not the treatment. Okay? So is everyone seeing how we're deciding if it was by random chance or the treatment? Okay? If it's not part of the random chance values, it's unlikely that it was by random chance, so it had to be by the treatment. Now, I have an issue, though. Is it going to be that explicit, that extreme on the outside, where you could say, definitely not random? What happens if you get a value right about here? Some of you are going to be like, it could be. Could be part of that, or it could be extreme. I don't know. Right? Everyone agrees? So I'm going to show you right now a mathematical way to determine if it's extreme or not. And that is what we did yesterday. And if you weren't here yesterday, I'm sorry. All right, you got to catch up on this part. Create a 95% confidence interval. Remind me, if I wasn't here yesterday, what was the formula I'd given you? Look back in your notes if you need to. How do you make that confidence interval again? You take your mean and plus or minus the, what do we call that? Plus or minus the? We're not there yet. We're not at standard deviation yet. It was mean plus or minus the margin of error. Okay. How'd you guys get the margin of error? That is the plus or minus 2 times standard deviation. So we do this after we do all these 100 simulations. Now using my simulation, what was the standard deviation? 0.186. Margin of error, go ahead in your calculator, plus or minus. .372. All right. Now find my 95% confidence interval. The mean, which was given as 0.006, 0.08, excuse me. Add the margin of error, subtract the margin of error. To find that interval right now, everyone go ahead, subtract 0.372 from it and add 0.372. And our confidence interval, negative 0.364 all the way to 0.380. Here's how we tell if it's random or not. If your score falls within your confidence interval, it's random. Where's our score fall? Where's our score fall? Outside. Okay, so it's not by random chance if it falls outside your confidence interval. All right, it is not by random chance if it falls outside the confidence interval. All right. Questions on how to get the confidence interval. So this observed difference, if it's outside the confidence interval, it's not by random chance, it's by the treatment. So let's answer the question. Would it be unusual to find this value, which was 0.467, based on this simulation chart? Would it be unusual to find that? Is it unusual to find that? Is it unusual to find 0.467 on that simulation chart we just did? Yes. And then our reason why from now on is going to be because it falls outside our what? Outside our, what did we just compute? Confidence interval. So the question I asked you at the beginning of class, could one conclude that swimming with dolphins decreases depression? Can we conclude that? Yes, because when it falls outside, it's not by random chance. And the only other explanation we have is because of the treatment. So yes, because 0.467 was an unusual occurrence. Not by random chance. Occurrence, anybody? A-O-C-C-U-R? E-N-C-E? Not by random chance. Because there's no assignment tonight and you got the rest of the time to yourself, which is very rare in this class. So let me just summarize everything again, what we're going to do the next 2 days. First thing we're going to do, we're going to subtract the differences in the means. Okay, we're going to subtract the differences in the means. Then we're going to create a 95% confidence interval. And we're going to see if that difference falls with, if it falls within, it's from what? If it falls within, it's by random chance that it happened. If it falls outside, it's not random, it's by the treatment. The treatment worked. All good? Because we're going to start that tomorrow. All right, that's all I got for you.